Hello everyone, my name is Ibukunolu Ademola. I'm here to take you chemistry and our topic for today is electrolysis. There are four objectives for today's lesson. The first one is that at the end of today's lesson, all the students should be able to define electrolysis. The second one is that at the end of today's lesson, every student should be able to define some of the terminologies used in electrolysis. The third one is that at the end of today's lesson, all the students should be able to draw the diagram of a simple electrolytic cell. And lastly, at the end of today's lesson, all the students should be able to differentiate between conductor and electrolytes. So what is electrolysis? Of course, I have two definitions to give. The first one, define electrolysis as the chemical decomposition of a compound brought about by a direct current passing through either a solution of the compound or the molten compound. And the second definition, define electrolysis as the chemical decomposition of a compound in molten state or in solution through the passage of electricity. But if you notice, you will discover that on this slide, I painted some of the words in red. The red ones are the keywords that every student must take note of while defining electrolysis in any exam. Alright, what are the terminologies used in electrolysis? The first one is electrolyte. An electrolyte is a compound which in solution or in molten form conducts electric currents. Examples are sodium chloride, hydrochloric acid, sodium hydroxide, and etc. and etc. And at the same time, we also have non-electrolyte, which is opposite the electrolyte. A non-electrolyte is a substance that does not decompose into ions, hence does not conduct electricity. Examples are sugar solution, urea, kerosene, distilled water, alcohol, and etc. and etc. Of course, we also have the category of electrolytes. We have the weak electrolytes and we have the strong electrolytes. The weak electrolytes are those substances that, whether in solution or in molten state, undergo slight decomposition and conduct electric current slightly. What are the examples? We have weak acid solutions, we have aqueous ammonia solution, and etc. and etc. Whereas the strong electrolytes are those substances that whether in molten state or in solution undergo considerable chemical decomposition and also conduct large amounts of electric currents. They are the one referred to as the strong electrolytes. What are the examples? We have solutions of strong acid, solutions of strong alkalis, salts, and so on and so forth. Alright, we are moving on. Electrolytic cell. What is an electrolytic cell? An electrolytic cell is an assembly of two electrodes, electric wires, and an electrochemical cell, generally called a battery. So if you look at the right hand side of this slide, you will see a diagram. That is a diagram of a simple electrolytic cell. So we have the anode, we have the cathode, which are the categories of electrode that I mentioned. We have the electrolyte there, and etc. and etc. Don't bother yourself about this. We are going to work on this in our next class. Alright, what is an electrode? Electrodes are conductors in the form of wires, metallic rods, or plates through which an electric current enters or leaves the electrolyte. They are the passage for electric current to enter the electrolyte or to leave the electrolyte. So, what are conductors? Conductors are usually metals or graphites that allows the passage of electricity through the movement of their mobile ions. Alright, types of electrodes. There are two types of electrode. We have anode and we have cathode. Anode is the positive electrode through which conventional current enters the electrolyte. And of course, anions migrate to the anode and are discharged at the anode. And at the same time, oxidation reaction occur at the anode. What about cathode? Cathode is the negative electrode through which conventional current leaves the electrolyte. And at the same time, cations migrate to the cathode and they are discharged there. Of course, reduction occurs at cathode. So the difference is that electric current enters the electrolyte through one, electric current leaves the electrolyte through the other. And at the same time, oxidation reaction takes place at one, reduction reaction takes place at the other one. The differences between a conductor and an electrolyte. The first difference between the two of them is that conductors conduct electricity in solid state, while electrolytes conduct electricity in molten state or in solution. The second one is that conductors conduct by the movement of electrons, while electrolyte conducts by the movement of ions. The third difference between them is that conductors does not get chemically decomposed in the process, whereas electrolyte decomposes in the process. And the last difference between the two of them is that conductors are elements, but electrolytes are ionic compounds in solutions or in molten states. Alright, what have we learned in our lesson for today? The first thing is that we've been able to define electrolysis through different definitions. And the second one is that we've been able to define some of the terms used in electrolysis. And the third lesson is that we have been able to also differentiate between conductor and electrolyte. And lastly, we have seen the diagram of a simple electrolytic cell, and so we should be able to draw it from now. That's all from me. Bye for now.